All right. So this video is to help you understand how you can reconfigure your Express LRS receiver for multiple output types. Okay, this is most helpful, at least at the time of recording this video, in our class with our planes, our fixed wing design and construction class, because we will use an Express LRS receiver in the normal format for one of our planes, and then we have to change some of the outputs on the receiver to give us what's called S-bus for one of our later planes that uses a flight controller that only accepts S-bus, basically. Okay, so I have the receiver already in Wi-Fi mode. You can see that flashing there. And then I have it pulled up on my web browser. If you don't know how to do that, go back and watch the other video or just Google it real quick. Basically, just connect to the Wi-Fi hotspot the receiver generates with the password Express LRS, all lowercase, one word, and you should get a web page pulling up that looks like this. We can see that my receiver here is Radiomaster ER5A or C, firmware revision 3.3, okay? All of that shows up on the page and we know we're connected to our receiver. Now we can change a bunch of settings. Okay, we have our options, Wi-Fi, and then we're going to go to the model tab for this video. And since this is a PWM receiver, we have this PWM output section. Okay, a lot of what I'm going to talk about is specific to this type of receiver, a PWM receiver. I'll talk about the other type of receiver that Express LRS uses in another video, actually. But most of this will be referring to the PWM receiver specifically. Okay. All right, so PWM output section here, we have our outputs and our inputs, and then we have some other options here. Okay. So outputs 1, 2, 3, 4, 5. This happens to be a 5-channel receiver. Okay, there's actually 6 sets of plugs, but one of them is for battery. Okay, the other 5 are right here. And so 1, 2, 3, 4, 5. Those are our 5 physical outputs. Okay, so when we see outputs here, that's what that's referring to. Saying, hey, pin number 1, or a set of pins number 1, is going to be at 50 hertz update rate, and that's fine. And it's going to be controlled by channel number 1 on our radio. Okay, if we need to reverse something, we can. If we want this 750 milliseconds option, we can do that. Or if we want to change our fail-safe position, we can do that. Some of you might remember this page from the fail-safe settings. I'm actually not entirely sure what the 750 milliseconds option is. I have to look into that some more. But if you wanted to change your fail-safe position for that channel specifically, you could change that over here. Okay. What we're worried about right now, though, is actually just the outputs and inputs. Okay. Express LRS by default wants channel 5 to be what's called an arming channel. So we need to have that channel turned on or high when we're ready to fly, because that turns on some of the things like dynamic power and other cool Express LRS features. Obviously, things will still move around. Your servers will still move and work and things like that if channel 5 isn't armed. But by design, the developers of Express LRS want you to arm on channel 5. Okay, which means if we're using a switch on our transmitter just to arm the receiver, we're not going to be also using that switch to control something on our aircraft, because then we would be turning it on and off, and that would be arming and disarming the receiver while we're flying. So that's not going to be good. So what we can do here, instead of having output number 5 controlled by channel input number 5, we'll just change it to 6. Okay. So channel 5 on a radio can still be used for arming the receiver, but now it can actually use that extra physical plug on our receiver, output number 5. Okay. We can actually still use that plug and control something. We just need to make sure whatever we control is controlled by channel 6 on our radio, if that makes sense. It's a little bit confusing, but it should be able to get that straight. So channel 5 would be used for arming and disarming the receiver, so it only travels from the transmitter to the receiver, and then it stops. There's no other signal sent anywhere else. We just say, hey, arm or disarm. Okay, but now if we want to use that physical plug number 5, we say, okay, I'm going to assign this switch to channel 6 in my radio. And channel 6 gets carried over to the receiver, and it transmits the information from channel 6 to output on pin number 5. So we still have a full 5 set of pins we can use to control stuff on our aircraft. Say we want to add flaps on channel 5, for example. We can still plug the flaps into number 5, but we control them with channel 6 here, because we're already using channel 5, for example, to arm our aircraft. Okay, so that's what the output mapping can do. You can change the channel outputs for different things. Maybe you have a certain setup you always like to use channel 10 for flaps. Okay, so you could change that to be channel 10 could output right here on pin number 5. Okay, maybe you have different receivers that have different numbers of channels and you don't like to change up your radio every time you change a receiver. Lots of reasons why you could do this, but just be aware that's at a minimum you'll probably want to do that. Channel 6 should be set to 5. Okay. But I guess the bigger point of this video is that we want to use a serial output from this receiver. So our flight test or light, which let's see here, flight test or light, which you hopefully recognize or you have received by now, or soon will receive. If you're watching the video a little bit early, that's fine. This is a flight control stabilizer, they call it. Basically, it'll go in your larger plane and help it to stabilize or have a self-leveling mode, kind of beginner mode type thing. This piece of hardware, the circuit board, this flight control stabilizer, does not understand, or we can't plug in all of our channels directly. We can't plug in 1, 2, 3, 4, 5 to this, this setup. We have to use what's called the serial protocol. That's where all the channels will go over one wire from the receiver to the flight controller. Okay. And so to do that, we need to use a serial protocol. And this flight control stabilizer board happens to not understand CRSF protocol, which is kind of the native Express LRS protocol. So we can't use CRSF, but we can use what's called SBus. So let's go back over here to the web interface. Okay. And so you see here in the mode section, this is the update rate for each channel. So 50, 60, faster updates can work for higher end servos. Our servos are fine on 50 hertz, so don't change that for your servos. Okay. But here on channel 2 and 3, we have another option in addition to the update rates. We have a serial TX. So I click on that, it now takes up 2 and 3 as serial TX and serial RX. I can't change them anymore. Okay, I can't adjust those at all, because what's happening is it's now saying, hey, send all the channel information over one wire that comes out of set of pins number 2, basically. Okay, and then if we're going to receive data, the RX would be receiving on pin number 3. Okay, SBus as a protocol doesn't really receive data, at least in this case, so we don't really do anything with number 3, but we also can't use number 3 for anything else. However, you see that 1, 4, and 5 are still available as normal servo or PWM outputs. And so what we can do is we can have all of our channels go over 2 and 3 and flow into the OR light flight control stabilizer board, while at the same time utilizing channel 1, 4, and 5 for extra stuff that we don't need the stabilizer to worry about, like flaps or a small bomb drop type mechanism where we drop a little foam board bomb or something. The stabilizer doesn't need to know about that stuff. It's not really going to matter. It's not going to stabilize a bomb drop mechanism. But we can still control it with these other channels directly. Okay, so this kind of gives us more channels effectively. Because what happens is all of our channels go through this serial line into the OR light, which has 5 outputs. And then we have the other 1, 2, 3 out. So we actually get 8 outputs, more than we had before either way. Okay, because our receiver in this case only has 5 outputs by itself, and the OR light only has 5 by itself. But since we get to use a little bit of both, we now have 8 outputs, which is kind of cool. Okay, so we'll set that to serial TX. And we'll go down here to serial protocol, and you can see there's a couple different options. I talked about CRSF, which is the kind of the native protocol for Express LRS, but the OR light doesn't understand that. The flight control stabilizer board doesn't understand CRSF, so we have to use SBus, which is an older protocol, and that's okay. And so that'll output SBus out of pin number 2 now. Okay. And then our SBus failsafe is important here as well. Okay, for the OR light flight control stabilizer to recognize a failsafe condition, as in to recognize we've lost link with our aircraft, we can't have no pulses, okay, because it just stops sending the data. And the OR light control stabilizer board doesn't seem to really recognize that well in my testing. So what we need to do is last position. It sends the last received channel data along with the failsafe bit. So that's the important part there. A bit being a small amount of electronic data. Okay, we need it to send the failsafe bit when it failsafes, and then the OR light detects a failsafe. So we have to set this SBus failsafe to last position instead of no pulses. Okay, once you've done that, you can hit save. All right, and that will save all your settings here, as well as the protocol and everything there. Okay, one last thing I forgot to mention: if we want to utilize these other outputs better, since channel 1, 4, 1 and 4 are already going to be on our control sticks. They're already going to be axes that we're using to fly our aircraft and that we want to go through the stabilizer. There's not really a point to having channel 1 still outputting because we're not going to plug our ailerons into channel 1. We're going to plug them into the flight control stabilizer so it stabilizes the ailerons. So instead of having input number 1 for output number 1, we can change it to something like input number 11. Okay, channel 11. Same thing for 4, we can change it to 14. Okay, easy to remember that way. But now we can easily set up other things to be controlled that get plugged into 1, 4, and 5. Okay, because we're using other channels than the normal control channels that we actually want to stabilize on the aircraft, being 1 through 4 are the ones we want to stabilize. Okay, so I'm going to go ahead and set 11, 14, and then I'm just going to go like this and set 15 so they're consistent instead of 6. So 1, 4, and 5 are 11, 14, and 15. Easier to remember, I guess you could say. All right, then we go ahead and hit save. Okay, set configuration, so that's worked there. Great. So now that's set, what we can do is we can, we need to basically repower on our receiver. Let me go back over here to the dock cam. We'll power up our receiver again, turn on the radio, and then I have a little tool here we can use to see all the channels moving around just from that single set of wires. Okay, so let's do that real quick. I'm going to unpower it, turn on the radio. Okay. All right, so we're going to power up the receiver now and get that bind. There we go, bound already, nice and quick. Okay, then we have this little demonstration tool thing. Just going to power this up with a battery so it turns on. Okay, what we can do with this, we'll try to zoom in a little bit here, is we can see different channels moving around from input from a receiver. So this will be just like this piece here will be kind of simulating what your aura light, okay, would be seen if it were plugged in and configured and everything. Okay, so I'm using a little jumper wire here, and this little jumper wire again would be going between your receiver and the aura light, but in this case I'm putting it into this little display so you can actually see what's going on. And I'm going to plug it into channel 2 on the receiver because that was our serial TX. Okay, so we're going to plug this into channel 2 here. Okay, I'm going to make sure I change this to S-Bus mode. Not measure. There we go, S-Bus. Okay, so hopefully you can see that. Okay, try to hold it like maybe right here. All right, oops, no glare. Okay, so as we move this around, you can see, if you look over here, so channel 1, 2, 3, and 4. So channel 1, see that moving back and forth? Okay. I actually have channel 4 moving as well because that's for the outlaw where the ailerons and are mixed to 1 and 4. Okay, 1 and 4 are moving there. We have channel 2 moving there on channel 2. Okay, and channel 3 moving on channel, oops, got to arm the aircraft, sorry. Channel 3 moving on channel 3. Okay, hopefully you guys can see that okay. As I move the sticks around, we get movement. All those channels are flowing over the single wire between the receiver and this S-Bus display. Okay, so on your plane, instead of the S-Bus display, you would plug this end into your aura light, which would then receive all those channels, just like you see it receiving here. And so that's really all we need to do to configure our PWM receiver to output S-Bus. Okay. All right, so that was the configuration with the web interface. In another video, I'm going to show you how to reconfigure this S-Bus with just your Lewis script on your transmitter. And if you want to, you can look at that video as well, but either way will work pretty much the same and do the same thing. All right, thanks.